Alright, this is section 6.4, part 2. We're going to complete graphing the log of base 3 of x minus 2. I'm going to go out to 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I'm going to go ahead and plot my 2 key points that I have. So 5, 1, so about there. And then 3, 0 here. Okay, so we have a domain that goes from 2 to infinity. The range goes from negative infinity to infinity, and we have an asymptote at x equals 2. So right here, there's x equals to 2. Now let's look at b. b is 3, so since it's greater than 1, this is going to be an increasing function. Okay, so what it should look like is something like this right here, going through those points. And then there it is right there. Okay, so there's our 2 key points. Now the domain goes from 2 to positive infinity, and the range goes from, okay, keeps going down, negative infinity for y, and this keeps going slightly up forever to positive infinity. Okay, so everything checks out. So there's our graph of this function right here. So let's look at this one right here. We've got b is equal to 6, so we know it's going to be an increasing function because b is greater than 1. We have x plus 4, so that means that we are shifting to the left by 4 units. So let's look at our key point 1, 0. Since I'm going to the left, I'm going to subtract 4. So that's going to give me negative 3, 0. And then that b comma 1, well, that's going to be 6 comma 1, but since I'm shifting to the left by 4 units, I'm going to subtract 4, so that's going to be 2 comma 1. Okay, so let me go ahead and put increasing here, and our domain is going to be x plus 4 greater than 0, so we're going to have minus 4, x is greater than negative 4. So that's going to go from negative 4 to infinity. Our range is going to be negative infinity to positive infinity. Okay, now our vertical asymptote, it was x equals 0, but then we shifted to the left by 4 units, so I'm going to subtract 4. So x equals negative 4 is going to be my vertical asymptote. Okay, so I'm going to draw my graph. I'm going to go out to 6 everywhere. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I'm going to go ahead and plot these 2 points. So negative 3, 0 would be right here. And 2, 1 would be here. Okay, at x equals negative 4, I have a vertical asymptote. So here's x is equal to negative 4. And I know that this function is going to be increasing, so it should look something like this right here. Okay, and then notice our domain goes from negative 4 to infinity. Our range goes from infinity to our negative infinity, positive infinity. And we have the vertical asymptote as x is equal to negative 4. Okay, now let's look at this one. Our b is 1/4. So now we know that this is going to be a decreasing function. Okay, we've got x plus 5, so that means we went to the left by 5 units. So the 1 comma 0, I'm going to subtract 5. So that's going to be negative 4, 0. The b comma 1, well, that's going to be 1/4 comma 1. I have to subtract 5 from that as well. So 1/4 minus 5 over 1, multiply that by 4 over 4. So this is going to be 1/4 minus 20 over 4. So 1 minus 20 over 4, that is negative 19 over 4. So we'll get a rough number for that. So 19 divided by 4, 4.75. So that's going to be negative 4.75. Negative 4.75, comma 1. Okay, and then we will find our domain. So I'm going to put x plus 1. I'm going to have that greater than 0. Okay, so domain is going to be x plus 5 is greater than 0. Subtract 5, so x is greater than negative 5. So from negative 5 to infinity, the range is negative infinity to positive infinity. And the vertical asymptote, it was x equals 0, but then we shifted it to the left by 5 units. So subtract it from 5. So x is equal to negative 5. Okay, I'm going to go out to 5. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I'll plot these 2 points. So negative 4, 0. So right here. And then negative 4.571. Okay, so that's almost to 5, so we'll say about here. So there's about 1 right there. Okay, my vertical asymptote is x is equal to negative 5, so there's that right there. And we are decreasing. Okay, so what this will look like is this right here. Now let's take a look at vertical shifts of the parent function of log of base b of x. So for any constant d, if you add it to the end of the log of base b of x like you do here, then it's going to shift the parent function up if d is greater than 0. It's going to shift the parent function down if d is less than 0. You're going to have a vertical asymptote of x is equal to 0 because that d is affecting the y values and not the x values. And your domain is going to be from 0 to infinity, and your range is going to still be from negative infinity to positive infinity. Okay, so how we're going to graph this is, we already said if d is greater than 0, it's going to go up. If it's less than 0, it's going to go down. We're going to draw the vertical asymptote x is equal to 0 because we didn't shift to the left or to the right. We're shifting up or down here. We're going to plot our key points, and then we'll have the domain from 0 to infinity and the range to be all real numbers and the vertical asymptote be x is equal to 0. So let's look at this right here. So we got log of base 2 of x plus 4. We'll say the domain, the range, and the asymptote, and we're going to graph this thing as well. Okay, so b is equal to 2, so that means that we're going to have an increasing function. Now let's look at our key point 1, 0. Now we said that this plus 4, that is going to affect the y values, so I need to add 4 to my y value, so this will be 1, 4. And then the b, 1, well, b is 2, 1. Again, we're affecting the y values, and we're going up by 4, so I need to add 4. So this will be 2, 5. Our domain is going to be x is greater than 0, so that will be from 0 to infinity. And our range is going to be all real numbers, so from negative infinity to positive infinity. And our vertical asymptote will be x is equal to 0 because there's nothing shifting to the left or to the right. Okay, so we're going to have, I'm going to go out to 5, so 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. We'll plot these 2 points, so 1, 4, and then 2, 5. And then our vertical asymptote, which is really just the y-axis, so x is equal to 0. And we said that this thing is increasing, so it should look something like this right here. Okay, now this one right here, b is equal to 3. So again, we know that this is an increasing function. Our point 1, 0, well, we're going down 2 units, so we need to subtract by 2. So this will be 1, negative 2. And then our other key point, which our b is 3, 1. Again, we need to subtract 2 from our y values. So this will be 3, negative 2 plus 1, that's going to be negative 1. Our domain is going to be x is greater than 0. So that's going to be 0 to infinity. Our range hasn't changed, negative infinity to positive infinity. And our vertical asymptote is x is equal to 0 because we have not shifted to the left or to the right. Okay, I'm going to go out to 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Plot these 2 points. So 1, -2. So here. 3, -1. And here. Here's our vertical asymptote at x is equal to 0. And we are increasing, so it should look something like this. Okay, then let's look at this one right here. Our b is equal to 1/5, so we are going to have a decreasing function. Okay, we're going down by 3 units, so 1, 0. Subtract that by 3, so 1, -3. The b, 1, which is 1/5, 1. We need to subtract that by 3 as well. So that'll be 1/5, -2. Our domain is going to be x is greater than 0. So from 0 to infinity, our range hasn't changed, -infinity to +infinity, and our vertical asymptote is still x is equal to 0 because we have not shifted to the left or to the right. I'm going to go out to 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay, I'm going to plot these 2 points. And 1/5, that's a 0.2. Let me show you on here. So 0.2, so a little bit past 1 here. Or sorry, 0. So 1, -3, that would be about here. And then 1/5, -2. So that's going to be about here. Okay, and we are decreasing. Let's go ahead and get our vertical asymptote. X is equal to 0. It'll look something like this right here. Okay, now let's talk about vertical stretches and compressions of the parent function log of base b of x. So for any constant a that is greater than 1, then the function with a times log of base b of x, that's going to be, you're going to stretch the parent function vertically by a factor of a if a is greater than 1, and you're going to compress the parent function log of base b of x vertically by a factor of a if a is between 0 and 1. So again, since we haven't shifted to the left or to the right, we're still going to have a vertical asymptote of x equals 0. We're still going to have an x-intercept of 1, 0, and we'll have a domain of 0 to infinity and a range of all real numbers. Now, this point right here, this a affects the y values. So if I took 1, 0, and what I'm essentially doing is I'm multiplying the a times the y values. Well, 0 times a, that's still going to give me 0. So that's why that point hasn't changed, even though we are affecting the y values. It's just because we have a 0 there, and anything times 0 is still going to be 0. Okay, so here is a couple of examples of a vertical stretch and compression. So here is our original function, just log of base b of x. So when we have a is greater than 1, well then it's going to stretch it upward. Notice how the y values are increasing faster when we have a vertical stretch. Okay, like it is doing right here. Okay, so there is a times log of base b of x. So the y values are moving more rapidly than it did for just log of base b of x. Now for a compression, so here is our original function right here. So log of base b of x. Now if we have, what we would have is a between 0 and 1. Or you could say 1 over a, and a being greater than 1. That'd be the same thing. Basically, if you have a fraction and it's greater than 1, but it's, or sorry, greater than 0 but less than 1. If you've got a fraction there and it's not a negative in front of it, we'll talk about when we have a negative in front of it, that's going to be a reflection. Okay, so if you just have a fraction in front of your logarithm, then what you have is a compression. So this would be compressed down. So your y values would be moving slowly